In my absence, what we have in this video are notes for lesson 3.4 and 3.5. Let's get started. Lesson 3.4 and 3.5 are on the law of large numbers and expected value and on counting principles. We're going to start with 3.4 as we talk about probability. So it seems like you would never buy a lottery ticket with the numbers 1, 2, 3, 4, 5, 6. But mathematically, that is just as likely to occur as 3, 6, 13, 26, 37, and 42. So similarly, if you've been playing at a slot machine in Vegas and you've lost the last 10 times, it seems like you should be keep playing because you're due for a win. But all of these are kind of gambling fallacies, and they have they're what we're going to address in today's video. We're going to start with expected value. Expected value really is what you would expect to win in any game of chance. So it's what you can expect to win in any game of chance, in any one game. Let's call that any single game of chance. And this is on average. So what happens here is really some people will win and some people will lose. But on average, what is the expected winnings or losses? And the way we calculate that is we call it E of X. And you take each dollar amount that you either win or lose. So X is the dollars times its respective probability. So there may be several ways to win, different dollar amounts. And their additional probabilities. And you add all those up to get your expected value. So let me show you how that works. In example 1, it says Valley View Elementary is trying to raise money to buy tablets for their classrooms. The PTA sells 2,000 raffle tickets at $3 each. The first prize is a flat screen TV worth $500. The second is an Android tablet worth $375. The third prize is an e-reader worth $220, and 5 $25 gift certificates will also be awarded. What are the expected winnings for a person who buys one ticket? Now, when we calculate expected value, the easiest way to do it is to write out a probability distribution before we start. So let's do that. I'm going to go over here, slide this down a little bit. All right. So for each item we have here, we have the dollar amount that you'll win, and that's going to be like your X. X is the dollar amount for your win, and P is the probability. So you could win a flat screen TV worth $500. But since you paid $3 for the ticket, we're going to call that winning really $497 because 500 minus 3. So 500 minus 3, 497. Now let's figure the probability of that. Only one person in the 2,000 raffle tickets is going to win that. So the probability here is 1 over 2,000. We're going to figure the rest of the values and probabilities similarly. So the second prize is an Android tablet worth $375. But since you paid $3 for the ticket, 375 minus 3 is 372. And there's one of those available also. So the probability of winning that is just 1 out of 2,000. The third prize is an e-reader worth $200. 200 minus 3 is 197. And there's only one of those, so the probability of winning that is 1 over 2,000. Then it says there are 5 $25 gift certificates. So if you won one of those, you paid $3 for your ticket, but you won 25 back. So your actual winnings are $22. My printer's going crazy. any of those. But since there are 5 of those $25 gift certificates being offered, your probability of winning that is 5 out of the 2,000 tickets sold. Finally, so those are all the ways to win. Of course, there are going to be a lot of people who lose, and if those people lose, they're going to lose $3. And how many people will lose? Well, if 1, 2, 3 people won the first 3 prizes and 5 won the 4th prize, 3 plus 5 is 8. So of those 2,000 tickets, only 8 are winning tickets. So 2,000 minus 8 gives us 1,992 ways to lose. So the probability of losing is 1992 over 2,000. Now we can calculate the expected value because we have all of the potential winning and losing amounts and their corresponding probabilities. So the expected value here will be the 497 times 1 over 2,000 plus the 372 times 1 over 2,000. That says 372. Plus the 197 times 1 over 2,000. And then plus the 22 times 5 over 2,000. And then minus the 3 times 1992 over 2,000. Now, the way we multiply these together, we know, is we put a 1 underneath those whole numbers. And we multiply straight across. So multiplying these two together, we're going to get 497 over 2,000. If we multiply these, we'll get 372 over 2,000. Here we'll get 197 over 2,000. Here, 22 times 5 is 110 over 2,000. And back here, we'll take 3 times 1992, which is, oops, that's not plus. Since all these tickets are losing tickets, this one's going to be minus. So we're going to write minus 3 times 1992 is 5,976 over 2,000. Now, lucky for us, on all of these fractions, the denominators are the same, so we just add the numerators together. And if you do that, you'll get a negative 4,800 over 2,000. Dividing that out, we get an expected value of a negative 2.4. All right, now what does this mean? When we do these problems on projects and exams, we're going to be asked to interpret what they mean. So a negative 2.4, remember the expected value is what you can expect to win or lose on average by buying one ticket. So in this case, what we'd say is lovely. Sorry. What we'd say is the expected value in buying one of these lottery tickets is that you would lose $2.40. So let's write that. So the interpretation is if you bought one raffle ticket, you can expect to lose, because the value is negative, about $2.40 on average.